Hello and welcome to our third video about the CFX solver. In this video we will tackle the setup step. In this step we will define the fluid properties, the boundary condition, as well as the solver parameters that will define our simulation run. So this step comes right after finishing the mesh, and once the mesh is updated, you want to double click on the setup icon and this window should appear. So the first step in this the setup process is to check that the analysis type is on steady state. It should be the case by default, so that's just a simple check. Okay. Then you want to double click on the default domain, and here we have all the fluid properties. We want to keep everything by default, so all these parameters should be unchanged, and here as well, except for the turbulence model. So we want to switch from K epsilon to shear stress transport. This is mandatory because the SST model that we're going to use has been proven to be more efficient and overall more stable than the K epsilon for wing simulations. We're going to apply and close this window. Afterwards, we are going to set the boundary conditions in the same by using the named selections that we did in the geometry video. So now we want to right click on the default domain, insert, and boundary. So let's start with the inlet, and here we can enter what normal speed do we want. So for example, just put in 10, apply. Then we want to do the same thing. We want to define the opening. So the location, as we named all the surfaces accordingly to the boundary conditions they represent, they should automatically take the location into account and the good boundary type, but to be sure, just check if this is the case, and if it's not, just change accordingly. Then we go into the boundary details and just put 0 Pascal, which means that there is no pressure difference between the outside and the inside flow. Okay. Once again, we want to define the symmetry. Here has the name of the surface is not symmetry. We have to manually select it, so just select symmetry. There's nothing else to enter here, so just apply. And finally, for the last one, we have to put on the wing. So the same problem here, just put a wall, and here in the boundary details just check that the no slip wall and smooth wall options are taken into account. Apply. Okay, so now we have every boundary. Every boundary has its own boundary condition, which is necessary to really start the solver. Finally, in this step, we want to go into the solver control, and here we have how the solver should behave and what parameters should it take into account. So here we have the convergence control. So I don't think you will have to modify these. So just leave them as they are. And here very important, the convergence criteria. So here what we want to change is the residual target. So for this first approach, I will just leave it to 10 to the power of -4, but the further you decrease it, the higher the precision of your simulation will get, but also the longer it will take the solver to run. So you'll also have this kind of, you have to choose what's the best compromise between the precision and the time you want the simulation to run. So I'm just gonna leave it like this. Apply. Okay. So this step was pretty quick, and we are already finished. And now I'm just gonna let you discover the next video about the solution.